All right, welcome to Guided Practice 13. This is section 4.4 on implicit differentiation. So we got a couple of problems to tackle today. Notice this first one is written implicitly. I've got x's and y's mixed together. And in particular, I have two product rules going on. So I'm going to write out each of my pieces for that. So for the first one, my function 1 is going to be the y cubed. And its derivative is 3y squared, but it's a y, so times dy over dx. The second function is going to be the x squared, right? I'm multiplying the y cubed times the x squared. So 2 prime is then just 2x. Now I'm going to do both of my setups here. So the second one, for this one, my function 1 is just plain old x. And its derivative is just 1. And then function 2 is plain old y, and its derivative is 1 times dy dx. Okay, so I'm going to have those two, and then on the other side, I just have the derivative of the x squared. Okay, so I'm ready to go. So my first product rule, I'm taking 1 prime 2, so that is 3x squared y squared dy dx. Convention when you multiply is that you put the number first, then any x powers, then any y powers, and then dy dx at the back. Plus 2 prime 1 is just 2xy cubed. Then I want the derivative of xy, and I have my product rule set up for that over here. So 1 prime 2 is just 1 times y, which is y. And then 2 prime 1 is x times dy over dx. Okay, and that takes care of the xy term. And then on the right, I have x to the 5th, so this is 5x to the 4th. Okay, now algebra is to simplify here. So the first thing that we want to do is we want to move our 2xy cubed and our y to the other side. So we're going minus 2xy cubed minus y. That leaves us with 3x squared. And actually, what I can do here, everything on this side then has a dy dx, so I can factor it out. So dy dx times 3x squared y squared plus x. And that's equal to 5x to the 4th minus 2xy cubed minus y. And then I just want to divide, so that gives me dy over dx equals 5x to the 4th minus 2xy cubed minus y all over 3x squared y squared plus x. And that's my final answer. Now, if I check, this has 3 terms in the numerator, and I should see 3 x's, which there's an x, there's an x, and there's an x. And I have 2 terms that contain y's, which means I should have 2 terms in the denominator, and I do. So that tracks. Okay. For number 2, I have a chain rule and I have a quotient rule involved here. So the chain rule I can do just fine. The quotient rule I want to write out. So my top is x and my top prime is 1. My bottom is the y, and the bottom prime is dy over dx. Okay, so what do we do here? Okay, so let's see. First thing, chain rule. So I'm going to bring down my 3, leave the inside alone, decrease my exponent by 1. No derivatives there of any x's or y's, so we just leave it. Times the derivative of what's inside. So times 2x plus the derivative of y is dy over dx. So that's the derivative of the first piece. The next piece is my quotient rule, and I have all my pieces ready to go. So top prime bottom is y, minus bottom prime top is x dy over dx. And then we have, let's see, the over bottom squared, so over y squared. And that's equal to 0 because the derivative of a constant is 0. Okay, so now what? So my derivatives are here and here. So the first thing I'm going to do is clear out my denominator. So I'm going to multiply everything by y squared. So what do I have here is I get 3y squared times x squared plus y squared times 2x plus dy over dx. And then the y squareds cancel in the next term. So y minus x dy over dx. Shh, 1 second. Dy over dx equals 0. Now, I need to get access to this one. So this one's good to go, but I need to get access to this one over here. So I'm going to distribute that term on the outside to both pieces. So that's going to give me 6xy squared times x squared plus y squared. No, hold on, I put the square in the wrong spot. This square belonged on the outside. There we go. And then plus the 3y squared times x squared plus y squared dy dx. Then I have plus y minus x dy dx equals 0. And now I've got them all multiplied out. So now I can subtract this y and this whole term, 6xy squared times x squared plus y squared from both sides. So that's a minus y and a minus 6xy squared times x squared plus y quantity squared. Okay, that leaves me with just my two dy dx terms on the left. So I'm going to have dy dx, factor it out, times the 3y squared times x squared plus y quantity squared minus x. And on the right, I have the negative y minus 6xy squared times x squared plus y quantity squared. And then the last thing I do is divide. So if I divide those two through, we end up with negative y minus 6xy squared times x squared plus y quantity squared over 3y squared times x squared plus y quantity squared minus x. And that's my final answer. Now, once you've got quotient rule going on, it's a little bit harder to kind of identify, I have this many terms in the top and bottom, and how that correlates to what's going on, because your derivatives are a little more complicated, particularly with chain rule and quotient rule. Also, please note that this is super tempting that you have this quantity in both pieces. That does not cancel out. And the reason for that is because it's tied using addition and subtraction to other pieces in the function. So you can only cancel if they're being multiplied by everything else. So it's tied together with addition and subtraction, so it's not eligible to be canceled. Okay, so there's our number 2.